Okay, so I'll start off by creating a new project. And the nice thing with these three parts and the assembly is that we can put everything in the same project. So for today, we don't really need to create all that many projects while we're working. So we're going to create one project to begin with. One new project there. Single user. I'll put it on my H drive. In my lecture folders there, and create a new folder. And practice tasks 7A. Also put in the name of the project as practice task 7A. Then I finish it off. So I'm just going to check that my microphone is working. Yeah, it's working. So then we're finished with the creation of the project, and we can start on our first part. So we'll create a new one. Go to the metric folder and use a standard in millimeters IPT file. And the first one we'll create is this one. So it's a very easy one to create. Just need to wait for loading. There. Done. I'll start a new sketch, putting it on the horizontal plane. I'll flip it 90 degrees to get it the right way around. And for this one, we can go directly for the slot function in the sub-menu on the rectangles. So if we do the drop-down menu, we can choose rectangle, so we can choose the slot one. So drop-down menu there, and we'll go down to slot. And the nice thing here is that we know the distance between the center points. So we can use the one that goes from center to center, and then you give the diameter of the slot. So I'll now place it just fairly randomly in a horizontal line, and I'm going to attach it to the center here afterwards. And it's supposed to be 65 millimeters between the center points. So doing now, it's slot there. Doing the width first. I'll have to check this one. Let's see what it says. No, we're going to do from start to finish there. Let's see here. So we start, and then we have the 65 millimeters. We lock it into place. Press enter, and then we get to set the diameter of it. And the diameter is going to be 35. Lock it into place with the tab button, and then I get it in there. So now I can zoom in a bit more just to get to see what I'm doing here. So I'll use the coincident constraint for this one in order to lock it to the center point on my sketch. So the coincident constraint, and I'll click on the middle of my slot, the midpoint there. And then on the center point in my coordinate system. So then I've locked it into place there. So then I can finish my sketch. Just zoom out a bit here. And we can do an extrude. And it's supposed to be 12 millimeters thick. Like that. And now we just needed 2 holes on it. So I'll use the hole function. And for placement, I'm going to use the concentric one. So that's going to place the center of my hole on in the same center as the curve on the edge. So I click on the plane on top of the plate that we've just created, and then I click on one of the rounded edges. So we get the same center, and the diameter of the hole is supposed to be 12. So I click OK. Actually, I could have clicked apply there, because then I wouldn't have exited the whole function. Yeah. Yeah, I'll just do the same for the other hole here, but I can wait a bit if you need to catch up. Ja, 35. Bredden. Lengden er 65. The diameter of the hole is 12 millimeters. Then we'll create the second hole also. So we'll do the exact same. For placement, we'll choose the concentric option. And the first thing it tells us is to select the plane, which is going to be the surface where we are going to drill our hole. So we select the top of our plate. And for concentric reference, we give the rounded edge of the plate. So then it places it on the same center point. And since I had already created one hole with 12 millimeter diameter, this one automatically popped up with 12 millimeters. So when I click OK, then it's in place. And the material we're going to use here is stainless steel. So we'll go up to the material drop-down menu up on the top there. We'll scroll down until we find stainless steel. So then we need to save our part. So I think I call this one base and small, or small base, or whatever you want to call it. Because the next one we're going to create, this one, that's going to be the large base. But I think before we continue on to the next part, we're just going to finish off the drawing for this part so that it's completely finished and ready for assembly. Because even though even though we are going to put these parts together, we still need to have separate drawings for each of the parts, because each part needs to be created individually or manufactured individually, and then they're going to be welded together afterwards. So we'll create a new drawing. So we go up to the new sheet up in the corner, and we scroll down until we find the iso.idw file. We select that one, and then we get a blank sheet up here. So we'll set our base view, and since we haven't closed down our part, it's going to automatically choose that one. So that's going to be our base view. I'm going to tilt it to the top so that I can see it this way. And I also want a projected view above it so that I can give the thickness of it. I could also put the projected view over on the side there. It's not really doesn't really make a difference. Maybe we'll actually put it on the side for this one. So we'll put it on the side there, and we need to scale it up a bit because it's fairly small on the drawing. We like to use as much of the sheet as we can when we're creating drawings. So we'll try a 2:1 scale. Might even work with a 3:1, but I think that might be just a little bit too big. I think 3:1 is a bit too big, so we'll go for 2:1 in this case. So I place it in there, and now I forgot to check how it was going to be shown, so now it's showing hidden lines on my projected view. So then I have to double click on my base view again. And I have to check that I have hidden line removed marked there. So that is the hidden line removed option. So once I click OK now, the hidden lines on this projected view are going to disappear. So then they've been removed. And now I can give each of the views a little bit more space, so I can move them a bit away from each other. So I can move it a bit more up here, and this one a bit more over to the side. And we're going to need some center marks and center lines on this one, because we do have symmetry on it. We even have double symmetry, both horizontally and vertically. But we also need center marks for the holes. So we'll go over to the annotate part of the toolbars over here. And I think we'll start off with the center marks. And here we have to remember both to put a center mark on the outside edge, but also on the hole. Because when we put on the outside edge, we don't get a center mark on the entire hole. So we have to click on both in order to get everything encompassed by it. And so long as you put center marks on both of them, it's telling whoever is going to manufacture it everything they need to know, because they know that both the hole and the rounded edge are going to have the exact same center. So that when they start creating the parts, they know where they're going to locate everything. So the same goes on the other side, on the rounded edge and on the hole. But in addition here, we could have a center line going across. So between the holes, we can have a center line just to show that it's symmetrical in both directions there. We can also have a center line going from top to bottom along the middle here to show that it is also symmetrical across on these sides, so it's possible to mirror it that way. And since we have the symmetry line going across here, we should put it on the projected view also, just to show where all the symmetry is. So then we should be ready to start putting in dimensions for it. And then I'll choose the dimension option, general dimensions. And we'll start off by putting in the length between the center marks that we have. So the distance from one center mark to another one. We'll put it down here, and now I have 65.00, so I don't want that. I'll go up to the formatting and choose default method 1B instead. So place this one out here, and we get that one up. Next, we could put the dimension in for the projected view just to get the thickness of the plate. So then we just choose the bottom line there. Place it out. And now I was lucky enough for it to actually connect it to the previous dimension I set, so that I'm getting them on the same line. If Inventor didn't do that automatically for you, then you can move your mouse pointer over to the previous dimension, and then it's going to snatch to it, so that it's going to place it on the same line. Place that one there. And then we can give the dimension across from the bottom to the top and over here. So then we get the 35 in width across it. And now the only dimension that we're missing right now is the diameter of the holes. But we're going to use the hole and thread function to set that one instead. So we go over to the hole and thread. We'll click on one of the holes. And now I need to change the method to method 1B again in the formatting. So I place it approximately there. But I also wanted to say that there are two holes. So I need to edit it. So then I first off have to exit the hole and thread function up here. So I have to exit that one, press escape or right mouse button and exit. And then I can double click on the dimension I just set. And I want the through part, I want that one to stay there, because I want everyone to know that these holes are going to go straight through the plate. But over on the front, I can place in the quantity note, which is this one. Quantity note there. But if you remember, when we created the part, we created the holes individually. So for now, it's just showing me that I have one hole. I need to go to the edit quantity note, and I need to choose the option of number of like holes in the view, which means that it is going to, Inventor will look for all holes that are 12 millimeter and going through the part, and it's going to count all of those. Then I click OK, and OK once more, and then we get 2 times 12 millimeter diameter going through. The next part will be to set out the general tolerances. I'll put it out above the title box. And as usual, we are putting in general tolerances and surface finish. And we're using the same ISO as always, 2768-1. And I think we're going for a medium finish on this one. So medium and ISO 2768-2. And the equivalent of medium is a K. I really don't want to do a Windows update right now. So I'll put in a K there. I've mentioned this earlier, but most likely when you're working for a company, this stuff here is going to be a part of their template, so that it's not something that you're actually going to write in every time you create a drawing. So it's a lot more automated when you're working for a company. So as long as the company is a bit up to date on how to use technology, they're at least going to put as much automated information into it as possible in order to save time when you're creating it. Then we click OK. And before I move that one into place, I'm just going to place the other notes down in the corner, since I'm already in the text box mode. So I'll just write in notes. And my first and only note is to break sharp edges. 0.2 at a 45-degree angle. When I worked in Imenco, the first note was usually always that the material certificate was supposed to be conforming to a certain standard, so that whoever manufactured the part also had to attach a material certificate for it according to a certain standard, so that we could prove that the material was what we said it was. That is a very common thing to require in the offshore industry. So then we'll place this one out there. Now I can exit the text box function and I can move my notes into a bit nicer locations. So we're not quite finished with the general tolerances and surface finish note. We need to put in the surface finish on it. So we go up to the symbol section, and beside the surface symbol you can see there is a symbol called welding. So that's a symbol that we're going to use when we get to the assembly parts today. So we're going to use the welding symbol and place it into our parts. But we're going to use surface texture now, as we usually do. Place it down here. We want our manufacturer to remove material, and we're just going to use the regular one of RA 6.3, which is a fairly okay surface to machine. So then we can exit our surface finish symbol, and we can place a parts list so that we get the material. So we click on the parts list and we click on one of our views and OK. Then we place it above the title box and we're going to edit it somewhat. So we'll go to the table layout, where we can remove the title. Then we'll go to the column chooser, where we can remove the present columns and we can add the material one. So we're going to remove the already selected ones, and we're going to add the one showing the material. So then we place the parts list down in the corner. I'm going to make mine a little bit wider so that I get stainless steel on one line. So I'm just going to pull a bit on the edge here and then move it down into the corner again. So now the only thing missing is our title box. I'll just give you a little chance to catch up, and then we'll fill in the title box. Then in order to edit our title box, we need to go over to the browser tree on the side here and to the ISO part and edit field text. Then we get this window up, and we need to open the properties in order to fix the information, and we go through the different tabs, filling in as we go along. Title, it was base small. Author will be our student number, and then we put in a company name before we continue to the next tab, where we will be filling out the part number and the revision number. Then on the status tab, we will fill in our checker and our approver. And the date of approval. So we click on OK, and then we get everything filled in. We're not missing any of the information that we need there, so everything is fine. The next step is to save the drawing. And we don't really need to close down everything now when we've saved the drawing. We don't need to close the drawing and the part file before we start the next one. We can just continue on because we're going to stay in the same project, and Inventor can handle it. You can have quite a lot of tabs up at the bottom here with many parts and drawings open. So that's not a problem. So we're going to save first off. Now this one is saved. It's gotten the correct name in the file name there, and then we can start a new part. So we go up to the new in the corner there, the blank sheet, and we choose another standard in millimeters .ipt. We click create. And now we've got the base part file, the base small drawing, and then we've got our second part that we've started working on. And it's not a problem filling in all of this with quite a lot of stuff. So now the second part will be this one, which is a bit more tricky to create, but it's a nice challenge to have. Just need to get the dimensions up here. So we'll start off with a new sketch. I'll place it on the horizontal plane. Now I'll rotate 90 degrees. And on this one, it's not going to be as easy to create it, but there is one thing we can do to lighten our workload a little bit, and it's the fact that if we make a line across the middle here, we have a symmetry line. So it's symmetrical on both sides, which means that we can start off by creating our symmetry line, and then we can create the top or bottom and mirror it afterwards. So I'll start off with creating a line, and I'll go over to the format option over here and create a construction line. And I'll create it not exactly on the center, but I create it as a horizontal line going across here, and I'm going to attach it to the center point afterwards. So once I've placed a random line here for now, and I'm going to remove the construction line option up top there. I don't want to create more construction lines right now, so I remove the marking on that one, and then I use the coincident constraint. So I figure out where the middle point of my construction line is, and I'm going to attach it to the center of my coordinate system. So now it's in place there. One thing I can do now is do the total length of the parts, which is going to be, I can set that on my symmetry line as the dimension of my symmetry line, and it's going to be 100.7 millimeters. So that's the total length from one side to the other side of the part. Then maybe we should start off with, if I have it over here, we'll start off on this edge. We'll create half of this height up above here. So we'll start a new line. I'll attach it to the end of my construction line there, and I'll move straight upwards, and the total length is supposed to be 35, but we only need half, so we do 35 divided by 2 so that we get the correct one, and we lock it in place using our tab button. So then we've gotten it locked in place, and we can place it with enter or our mouse button. And for now, we're just going to create a line going somewhere up here. So basically, we're just starting off on this line. We don't quite know what the angle is going to be or anything, because it's going to be attached to the rounded edge up top here. So we're just placing it here, and we're going to constrain it later on and get it attached to that end. So we're just placing it up like that. And we exit the line function, because now we've gotten the start off on this side. Now we need to start on the other side and move up there. So the first thing we're going to do now is actually create the circle. That's going to be we're going to create a circle basically, and then we're just going to cut it later on, so that it's going to be just a rounded edge afterwards. So we'll do the circle option, and we'll place it somewhere around where we think it should be. We'll pull it outwards, and we'll set the radius to be 17.5. So in this case, we need to do 2 multiplied with 17.5 in order to get the diameter of our circle. Then I'll just exit the circle option there, And I'll let people get a chance to catch up before we dimension it into the correct position. Ja, den skal være tilfeldig. Vi skal feste den på sirkelen etterpå. So just to recap what I did, we've got this green line that's going up here now, and I just placed that one randomly. Because later on, when we've gotten the circle in the correct position, we're going to attach the end here tangentially to the circle. So then we're going to get a perfect transition from a straight line and into the curve of the circle. So then we'll start dimensioning in the location of the center point of the circle. So I'll use the dimension option. And I'll start off by giving the dimension from this end and over to the center point. So from this end of the construction line, so I'll mark that one, and I'll also mark the center of the circle up there. So I'll pull it downwards in order to get a horizontal dimension on it. If I have it too far to the side, I'm getting the vertical one. We'll be setting that one afterwards. But first off, we're setting the horizontal one. And this one has to be the exact same as the radius here, because it's supposed to be go over into a straight line going downwards. So what we can do here is to just set it, we can mark the diameter of the circle. And then it says D2. It was the second dimension that we placed in there, so it's named number 2. D for dimension and number 2. And we divide it by 2. So that means that if we change the diameter of this circle later on, if we, for example, put it to 40 instead of 35, then it's also going to change this dimension, because they are connected to each other now. So what it says now, it is putting in fx for a function, and the answer to the function is 17.5, which is the radius of our circle. So if we change the diameter of the circle, then it's also going to change this dimension afterwards. So it's a nice way of making sure that if you change an integral part of your design, the rest of the design is going to follow if you do it this way. D2 is just the name of this dimension now. So it's just like putting in x. So if you call the diameter of the circle x, then the function here is x divided by 2. So each diameter, every time you place a dimension, it gets its own name, so that you can click the dimension and then you can use it in an equation. Now we also need to set the height of our of the center point here. So from the construction line and up to the center point of the circle. And in our drawing, we will see that there is 112 in total between the center points. So we do 112 and we divide by 2 to get the distance from the center and to the center of our circle. So now the circle has turned dark blue, so we know that it's locked into place. It can't move anymore. And then before we have a 15-minute break, we're just going to attach our loose line here. So we're going to attach it to the circle so that it's not just flying off in the into empty air there. So what we do then is we go up to the constraints and we find the one that's and we click on tangent and we click on the line and then on the circle. So now the line has been set to be tangent with the circle. But you can see it's not going all the way, or if your line was much longer than mine was, it's going way past your circle. So what you do then is do the coincident constraint, and you click on the end point of the line, and you click on the circle. So now we have a perfect transition from a straight line and into a circle. So then we'll have a 15-minute break. Okay, so we've gotten this far. Basically, the only thing we need now is to finish off the line on this side and trim the circle a little bit, because we don't need the entire circle. So we'll create a new line and we'll attach it to the edge of our symmetry line. And here we are going to hit the exact 90-degree angle of the circle. So there will be one of those green dots there which we can connect to. We don't need to do the tangent stuff on this one. So we just go upwards until we get it. Actually, Inventor is even telling me here that it's going to be a tangent when I connect it there. So then we get a full connection there. And then we can trim away the rest of the circle here that we don't need. So then we go up to our modify section up here. And we find the one that's called trim with a scissor on it. And you'll see right away, as soon as we move our mouse pointer across the section of the circle that we don't need, that it's marking it with dashed lines to show that it can cut away what we don't need. So when we click on it, it removes what's unnecessary there, and then the rest just stays in place. So then we can do a mirror of this one. So we'll do the mirror function, and we'll select the lines and the arc of the circle so that all of them turn bright blue. But it's important in the select phase that we don't click on the symmetry line, because the symmetry line has to be our mirror line, and we just get an error message if we try to mirror our mirror line. That doesn't work. So then we switch to the mirror line option, and we're going to click on the symmetry line. And then this is the silly one that's different from all the other functions in Inventor, where we have to press apply in order to continue. So once we press apply, it actually mirrors the function, mirrors the lines. Then we click done. Then we can finish our sketch. I'll zoom out a bit so that we can get to see it a bit better. And then we can extrude it. And the previous plate that we extruded was 12 millimeters thick. And they're going to be on the same line here, so this one also has to be 12 millimeters. So we'll put it at 12, not 123. So 12 millimeters, and press OK. Now we need to put in the 4 holes that we have here. So then we're going to use the hole function. Actually, I'm going to show you a different way of placing the holes. We're still going to use the hole function, but we're going to use a sketch to place points where the centers of our holes are going to be, because then we can use the hole function and it's going to create all 4 holes in one go. So we'll create a new sketch on top of our plate, like this. And then we'll go over to the point function on the create part of our toolbar. And then we'll just create 1 point over here and 1 point over here. And we'll do the same on the other side here, so that we get 4 points created in here. Now these are not locked into place in any way, that's why they're all green. So we're going to have to put dimensions on them to lock them into place. So we have 4 points placed in. We're going to use dimension to lock them in here. So first off, I'm going to take the distance from the top line here and down to the lines, to the centers of our holes. So from the top line and to this point, then I'll look at the drawing, and it's supposed to be 20 millimeters. So now I've gotten the correct distance on that one. Then I'll do the next point. And that one is supposed to be 42.3 millimeters. So now I've gotten that one also pushed down to the correct position there. Then I'll do the dimensions from the center point of my coordinate system and over to one of these lines. And that one is supposed to be 69.8 from point to point, so we need to divide by 2 here in order to get just half the length. And then we'll do the same for the other point over on this side. And it's supposed to be 102 in total length between those top points there. So 102 divided by 2. So now we've gotten these 2 points have now become dark blue. So they are locked into place. We can't move those points anymore. Now we just need to be able to lock these 2 points into place also. So a very quick way of doing that for now is to just continue giving dimensions from the center point. So I'll click on the center point, and then on the point over here. But before I push in any dimensions here, I'm just going to select the corresponding dimension on the other side there, so the one that's 34.9. So if I just select that one, it now says D9 because that's the name of this dimension. And if I just press enter now, it says that this dimension is a function and it's supposed to be 34.9. So if I change this one, we can actually do this just to show how it works. If I alter this dimension now, so let us say that I put it to 40 instead, then this one also changes to 40 because it's just following the other dimension. So I'll show this once more. If I change this dimension now, you can even see the name of the dimension here. It says D9 here on the name. So if I change it to 34.9, then this one that has the FX in front of it also changes to 34.9. And that is because if I click on this one to check what it says that it's supposed to have the exact same dimension as D9. If I had added some sort of math equation to this, then it would put that into context with the dimension of D9. But so long as it just says D9, it's going to be the exact same dimension as D9. If we go back, I just switch out from this one. So if I open the original one again, then it says D9 here. And if I go back to the one I was just in, I have to exit that one. You can see this one is named D11. So we know that. So if you actually remember the name of it, you can just write it directly, but it's much easier to just actually just click on the dimension, and it's going to automatically choose it for you. So then we do the same for the 51 dimension. So we're going to start off here and put it over to this point, giving it the same dimension as that one. So I start off at the center point of the coordinate system, over to the last point, place the dimension, and then I click on the 51 dimension there. Now it says D10, which is the name of this one. So when I push enter, it changes to 51. But there is still something that we're missing. We don't have the heights of these two last points. Now there are two ways of doing this. We could either continue on with the same stuff that we've done here. We could give the height and then just click on the corresponding dimension on the other side. Or we can use the horizontal or vertical constraint, depending on how it's been rotated and everything, to set it. But just to get to a more repeat of using other dimensions for setting a new dimension, we're just going to do it in the same way. So I start off at the top. I go down to the point here, and the corresponding point would be this dimension. So I set this one, and then I click on the corresponding dimension. Click enter, and I get it set into place. Then I do the same for the last point. Click on the corresponding dimension on the other side of the part, and set it into place. Now the nice thing is that everything on this side has got functions, so that if I want to change dimensions here, if I change them on this side, they're going to be mirrored over on this side. So what I've basically done here is I've done a manual mirroring process where I've mirrored all of my dimensions across it. So instead of creating a symmetry line, I've just set the dimensions. So this was a sort of complicated process for mirroring it. I could have just placed those 2 points in the correct location, created a symmetry line, and used the mirror function. That would have been quicker to do. But now you know of a different way of doing it, because if you just have one point that you're going to mirror, it's just as easy doing it with dimensions instead of doing it with a mirror function. And that is sort of the thing about using CAD software, whether it is Inventor or some other CAD software. You usually have quite a lot more ways than one in order to achieve your goal, so that there's always something to look for in other ways of doing it. Which also means that if you're looking at YouTube at different courses in Inventor where they're doing stuff, they might be doing it completely differently from what I'm used to doing. So that's because they're working in their way, what they find as the easiest way of doing stuff. So then we do finish sketch. So now we have 4 points that are placed in a sketch. And if we now go to the whole function, we click on the whole function, and it's going to automatically choose all 4 points. Because it's doing, if you look at the placement part up here, it tells us that it's choosing the points from a sketch. So since we have a sketch with points placed on it, it automatically chose that one for us. So in this case, our holes are to be 12 millimeters here also. So we put the diameter in at 12 millimeters, and all of them are going through. So we can just click OK. Then we just need to set the material to stainless steel. So we open up the material menu there, and we go to stainless steel. So I'll let everyone get a chance to catch up. Nei, jeg lagde bare punktene. Jeg brukte hold-funksjonen. So the next step will be to just save our part. And once I open my save as function here, we can see that there's the first part we created, base small, because we're still in the same project. So now we can see the files that we've already created there. And this one will be our large base. So base large I'm going to put in. I'll save it. So now I've got the part file for base small, the drawing file for base small, and I've got the part file for base large. So the next step will be to create a drawing for this one. So then we go up to the new sheet up in the corner there, the blank sheet button. We go down to find the ISO.idw option. Then we click Create, and we've gotten a new drawing with a blank sheet. So then we'll put in a base view. And the nice thing now is, even though I have two part files open, I've got base small and base large open, it automatically selects the previous one I was looking at. So since I just looked at base large, it has automatically selected base large for me. But if I open up the drop-down menu here, you can see that I still have both to choose from if I wanted to. But we've already created the drawing for base small, so we're going to create a drawing for base large now. And here it's trying to make me use hidden lines. I don't want that. So I'll remove that one, and then I'll flip it a bit around here, over on this side. And I'll do a projected view over on this side. This one we can also enlarge a bit. But 2:1, that was a bit big. So we'll just use 1:1 on this one. We'll click OK, and then we can just move it a little bit off to the sides here. So then I'll go to the annotate part of the toolbar, and I'll place my center marks And one thing you'll see here is that the center mark of the rounded edge is not the same as the center mark of the top hole. So when I'm placing the rounded edge here, it ends up over at the edge of the hole instead. So here it is especially important to show the center marks of both. We can also place our symmetry line, but in this case we only have a horizontal symmetry line because we can't mirror it this way at all. So we'll place a horizontal symmetry line there, and then we'll also place one on the projected view over on the side there, so that we're showing that both parts, that it is symmetrical either way how you look at it. Then we can start placing our dimensions, and since we have a symmetry line, we can place our dimensions across it as we usually do there. So put dimension, and then we'll start off with the smallest dimension so that we can work our way outwards. So we'll start off with the dimension between these holes, and I need to switch to method 1B in the formatting. So then you see we get 69.8 as our dimension. So then I'll move on to the next dimension, which is the next holes here. So from one hole to the other one, place this one in, and we got 102 between those. And the last dimension there will be between these center points for the rounded edges. So from one center point to the other. And there we have 112. Now, even though we're going to give the radius of the edge here, it might be nice to actually give the total width of the part over on the other side here. So we'll give it from here to there, being 147. But this one we need to put in as a reference dimension because it's dependent on the radius of the rounded edges. So we need to mark it as reference so that we get the parenthesis around it. Because the only reason we're putting in this dimension is to make it very easy for the machinist to control it, that the dimension is approximately 147, and then if it's way off, he'll have to go in and start looking at where are the center points on these rounded edges and what are the exact radiuses of the edges, because then you have to use special measuring tools in order to get those dimensions. It's much easier to just do a linear dimension across the entire length there to check that you're within your tolerances. So we put this one in place. We'll also put in the radius. On the edge there. And here we want to, before we finish off placing this one, we want to go over to the text option and add typical behind it so that we don't need to put the dimension on both of the rounded edges. In fact, we don't need to put typical in it because we have a symmetry line, so it has to be symmetrical on the other side. So that would be unnecessary to put typical in it. If this one has 17.5 millimeters and we have a symmetry line, then the other one, of course, has to be 17.5 also. But we still don't have the length dimensions that we need to put in here. So we don't need to give the length dimension into the center point here, because that's given from the radius. But we need to give the holes, and we also need to give the total length of the plates. So we'll start off with the first hole. So we got that one into place there with 20 millimeters. Then we'll put the dimension to the next hole into place. And this one is 42.3 millimeters. So this is sort of a typical problem when you're a mechanical engineer, because if you were free to design this as you would want it, you would probably set it as 42 millimeters and this one as 70 millimeters, just so that you got whole millimeters, whole numbers, instead of having decimal points in there. But what is likely the case here is that you've gotten a hole pattern in whatever wherever you're going to mount this with the bolts on. So you have to have your holes in certain locations for them to match up with the hole pattern where you're going to mount it. And that means that you can end up having these point something dimensions. So it's not ideal from a designer's point of view to have dimensions like that, but sometimes you just have to. You're not able to change what you're going to mount it to. Then we'll do the total length of the part here, which is 100.7. And then we'll give the dimensions across here. Now what we should do on this one is to add the reference stuff on this dimension. Do you have a question? It's not a problem having the radius crossing like that. The only thing you have to make sure of is that it is at an angle. So you don't want a straight line. So if I sort of pull it, it's not going to show properly here, but I really don't want it to be at a straight line. So when I'm putting a radius, I want to have it at an angle, because that makes it very clear that it's not a part of these other lines. So then it's not a problem having it cross. But if you think it's better to put it up top, that's going to be look even nicer, then you put it up top. So it's not a problem. For this dimension, we should actually add the reference for this one also, because it is really controlled by having the 35 millimeter there and having the 112 between the center points, and the fact that it's going to be a tangent on the radius there. So it's going to sort of lock it in place anyway. When you start following the outline of this one, the length is actually defined by other dimensions, not the total length dimensions. So we're just putting in a reference point here. So we just double click the dimension so that we can open up this window, and we set it as reference so that we get the parenthesis around it. And we click OK. Because again, like with this dimension, we only give this one to make it possible to do a quick dimension check for whoever is creating it. Then we're almost to the end of our dimensioning part. We need to set the thickness of the plate, and we also need to set the diameter of our holes. So we'll use dimension again. Need to switch it to method 1b because I've been exiting my dimension function. So then I set the thickness of the plate. Would be nice to get it attached to one of these. Get it on the line. And then I'll use the hole and thread function to set the dimension of the holes. And again, we need to switch the method. We'll put it in there. We exit the hole and thread function, and we're going to double click the dimension so that we can add a quantity note. We go to the front of the text and we press quantity note. And in this case, we had placed 4 points in a sketch, and once we used the hole dimension, it created all 4 holes in one go. Which means that we don't need to edit our quantity note, because the default option is to show how many holes you created at once with that hole function. So when we click OK now, we get 4 times 12mm diameter holes. So then we're over to setting our tolerance notes. General tolerances and surface finish. ISO 2768-1. We had medium and K on the previous one, so we'll use that on this one also. So medium. ISO 2768-2. Capital K. I'll click OK there. Since I'm already in the text function, I'm also going to add the note in the corner. Notes. 1, break sharp edges. 0.2 by 45 degrees. So now I can move the notes a little bit to make it look nicer, like this. So then I need to add the surface finish symbol beside the note. And I want the manufacturer to remove material when they're creating it, so that we are ensured that we will get the correct surface roughness. And we put in RA 6.3, like in the previous one. Since we're going to weld these together, it's nice that they have the same surface finish on all of the parts. Then we need to place a parts list to get our material. So we choose the parts list, click on one of our views, and OK. Place it down by the title block. Then we double click it so that we can start editing it. We go to table layout to remove the title. We click OK. Then we go to the column chooser and we remove the 4 columns, and then we add the material column. We click OK. And then I'll just make it a little bit wider and place it in the corner. So then we need to fix our title block. So we go over to the ISO part in the browser tree and we edit field text. We open up the properties and we start fixing the information that we need in here. So we put in base large as the title, put in the student number as the author, the company name, the part number, and the revision number, the checker, the approver, and the date of approval. Click OK, and then I just check that all of the lines have been filled in. And click OK again. And I'll save my drawing. So here we can see that the other drawing is present in our folder. And we'll just save so that we get this one also. So before we start our break, we can just open up a new part, which is going to be the last part that we're going to create before the assembly. So we're going to create this one right after the break. So I'll start up with a new file up in the corner there. Click on new. And then I have the standard in millimeters IPT file again. And I'll click on create. We got a couple of minutes left before the break, so I think I'll just start off with the first sketch also, so that we can start looking at it. So we'll create a new sketch, and we'll choose one of the planes here. This time I'm going to choose one of the vertical planes, because I want my first sketch to show this outline. And then I'm just going to extrude it. So I want it to look like this when I'm looking at it. So I choose one of the vertical planes. Then I just need to find the dimensions. I'll create the baseline first, which is the bottom line of the part. And it's going to be 137 millimeters. And this time I'm just going to attach the starting point to the center of my coordinate system. There is, when we're looking at it from this side, we don't have any symmetry at all, so we can't really exploit any of that. So it doesn't really matter if we've got it completely centered or not. So I'll just start at the center point, and I'll move off 137 millimeters to the side, and just make sure that it becomes trapped into a horizontal line there. So we want it to be, gotta zoom out a bit to get it to constrain itself. So there I have it constrained horizontally. And we're basically going to do the same as we did for this one when we created these rounded edges. We're going to create just a circle showing this rounded edge. And it has a radius of 30, so we need to do 30 multiplied with 2 to get our diameter. And then we're just going to lock the circle in place using dimensions. So again, we'll do the length from the end here and to the center point, the horizontal length. And again, we'll use the trick with selecting the diameter of the circle. But we don't want the diameter, we want the radius, so we're just going to divide by 2. And we're going to click enter. So then we get it perfectly on the same line as the center point in our coordinate system. Now we just need to set it at the correct height. And the height to the center is to be 27.7. So then we've got the outer circle here in place. We're going to trim it after we've created the rest of the outline. But we'll do that after the break.